Hello everyone. Today I am going to discuss about the course Optoelectronic devices. So these are the course content enrolled in this optoelectronic devices. So in this video I am going to discuss about the basic nature of light and the polarization. The rest of the things will be discussed in the upcoming videos. So before we are stepping into the topic, we have to know what is meant by an optoelectronics. For that, I am dividing this into two segments. One is opto, another one is electronic, which means opto is a light signal. The electronic includes the movement of electrons. So I'm combining these two things. It converts a light into an electricity. In this modern world, there are n number of applications using these optoelectronic devices. The few applications are optical storage devices, fiber communication, and LCDs, LEDs, lasers, solars, or painless therapy. Like that, it is used in many applications. Then, in initial stage, in 17th century, the both scientists have different views about the nature of light. One says light is a particle, another one says no, it is a wave. So both of them separately conducted an experiment to prove their statement. Isaac Newton says a light is a particle. Huygens says a light is a wave. So whether light is a wave or a particle, Isaac Newton believes that light travels in the form of particle. Then Huygens says light has a wave nature. So, in Huygens deduces the law of reflection and refraction, and he proves that light has a wave theory. Then later on, Huygens failed to prove a strong evidence about the light nature. Later on, Newton has practiced to prove light as a wave. Likewise, Likewise, each scientist has carried out their own experiment to prove light is whether a particle or a wave. Later on, Louis de Broglie had proved light has both the particle. It sometimes acts as a wave and sometimes it is act as a particle. So this is the evaluation of the nature of light. This is how it becomes. And the next is a light. We all know light has a dual energy. So how we can calculate the energy of an light? We simply know what is meant by an Maxwell's theory. Then we know what is meant by a speed of the light and wavelength of the light. I am considering all those things together to establish the energy package of a light. So, light has a dual nature. It has a electromagnetical waves which obeys the Maxwell theory. And also, I know the speed of the light c is equal to 3 into 10 to the power 8. Then I can easily establish the equation energy package E is equal to hc divided by lambda. Here h is the Planck's constant and c is the speed of the light. Lambda is the wavelength. Fine. So the few properties of light is it can uses the propagation and polarization. Interference will also occur, diffraction, radiation. Then the properties of light. This is a tabulation which shows the variation of colors in light has a different wavelength and the frequencies. So light with a wavelength less than 400 nanometer is called as a ultraviolet rays, which is higher than 700 we call it as an infrared rays. Likewise, each color of the light has its own wavelength. Fine. So next is a theory of light. So we know it has a two nature, one is wave, another one is theory. So Louis de Broglie has conducted an experiment and also the quantum mechanical theory concept to prove it has a duality concept. So, how we can establish the nature of light? How we can calculate the speed of the signal, light signal? We know the value of the speed of the signal c is equal to 3 into 10 to the power 8, but we don't know how it comes. In 1864, Maxwell combined the equation of electromagnetism in a general form and shows the existence of the transverse magnetic waves. Here I am establishing the equation of speed of the propagation of the light. C is inversely proportional to the square root of permeability and permeability of a space space. Then I am substituting the values of mu naught and epsilon naught to find the value of speed of the signal. So likewise it occurs. And the next is wave nature of the light. So I am going to now explain about the nature of the light as wave. For that I am considering a light as an electromagnetical wave which has a combination of time varying component, electric field and the magnetic field, which starts to propagate in the free space environment. While we considering the two fields, we have to go for partial differential equation. So del square of E comma H is equal to 1 divided by C square dou square divided by dou T square of electric and magnetic field. So this equation is called as the wave equation. So we know the relationship between a wavelength and the frequency. So lambda is equal to C by F. We know that relationship. So I am equating that relationship over here. Fine. And the next is, if we are considering the any other medium rather than the free space, we have to know what is the speed of propagation. So here the speed of propagation is equal to C divided by speed of the signal divided by the n. N represents as the refractive indexes of the medium. We know in optical communication we have came across as the term refractive index. So n, it is for air, it is considered as when. It is for water, when 0.33. It is for other medium, it changes. So depends upon the different medium, the value will change. Propagation will be a change. So V is equal to speed divided by that refractive indexes. So V divided C divided by N. Later you have to substitute the relationship between the wavelength and frequency to obtain the speed of propagation. Fine. So N is the refractive index of the medium like air and water and whatever it may be. So N is equal to the square root of mu r into epsilon r. Mu r and epsilon r or the relative permeability and the permittivity of the medium respectively. Fine. So light waves are transverse wave in nature. So I am describing the optical phenomena in by omitting the magnetic field vector. I am considering only the electric field component over here. I am considering a sinusoidal signal and I am writing that sinusoidal in terms of mathematical expression. Ex is equal to E naught of cos omega t minus k z plus phi naught, where Ex is the electric field along the x-axis at the position z at the time t, and k is the propagation constant value 2 pi divided by the lambda. Lambda is the wavelength and omega is the angular frequency. We know omega is equal to 2 pi f. So next is E naught. E naught is the amplitude of the sinusoidal wave and phi naught is the phase constant at t is equal to 0 and z is equal to 0. And omega t minus k z plus phi naught, the entire thing is called as the phase of the wave. So I am going to find the phase velocity of the light signal. So with respect to the time and the spatial evaluation, the given phase signal is considered with a maximum field. So phi is equal to omega t minus kz plus phi naught equal to a constant value. So I can establish the relationship of phase velocity with respect to the wave, with respect to the sine wave at a maximum field. So V is equal to del z divided by del t. So both are position and time. So I am rearranging to omega by k, that is equal to, substituting the value, we will get lambda by V by lambda. So if test t is equal to 0, the spatial variation of the electric field can be given by, in this equation, while we are substituting k equal to 0, we will get Ex is equal to E naught into cos of minus kz plus phi naught. So that is writing over here, and the other one, if it is x is equal to 0, we will get Ex is equal to E naught into cos omega t. So I am just substituting t equal to 0 and x equal to 0. While I am substituting t equal to 0, it occurs in the spatial coordinate, otherwise it occurs in the time parameter value. Fine. And in order to find the group velocity, so group velocity is dou w divided by dou k. I am doing a partial derivations of the phase velocity over here. And this is the schematic diagram, shows the variation with respect to time and with respect to the spatial coordinates. Fine. And the next one is a principle of superposition theorem. So we know what is meant by and how to calculate an electric field. So principle of superposition states it is a sum of individual signals. So I am finding the electric field of an individual signals, and I am summing more than 2 or more signals to find a resultant electric field. So E is equal to E1, E2, E3 up to it goes on. These are E1, E2, E3 are the electric fields of the individual waves at specified time. So now I am writing each fields. E1 is equal to, as per the previous equation, I am just writing the same one. I am putting the notation as when to, like that. So when x1 and x2 sine of omega t minus kx plus phi 1, we are writing next one is phi 2. Likewise I will write. Then I am substituting in that general equation and simplifying that, I will get the principle of superposition concept. That is about principle of superposition. And the next one is polarization concept. We will discuss the remaining topics in the next video. Fine. Thank you all.